So example 4 here, it's a solved question. We have a double angle in it, so the question is this a multi-revolution one, or is this one that we should change our double angle trig function using the identity? Use the identity because we have another trig function. So sine 2x is 2 sine x cos x minus cos squared. If we multiply the half by this, the 2's are going to cancel out. And we have sine x cos x minus cos squared x. Now, in this one, if we wanted to, we could change the cos squared to 1 minus sine squared. But that still wouldn't change everything to have the same trig function, because we'd still have a cos x over here. And we can't change the sine x because it's not a sine squared. So there's no way that we can change everything to be the same trig function. At this point, looking at other things, we're probably going to see if we can try to factor. Now, there is a common factor between the two of them. We can factor out a cos x, but this one, different than the other ones that we've had before, after we factor, what we're left with, here it's fine. Here you can say, I know for sure cos x is equal to 0, but our next bracket still has both sine and cos. What does this mean? If it's going to equal 0, what does this set of brackets mean? How would you make this equal to 0? They would have to equal each other. You'd have to have sine x equal to cos x. Now, we've done this question before. Right? You might just remember it from your pi plate. When is sine equal to cos? Pi over 4. So you could have quadrant 1. Any other quadrants where sine is equal to cos? Quadrant 3 at 5 pi over 4. So one way to solve sine equals cos is just think about your pi plate and think, I know that they're equal at pi over 4 and 5 pi over 4. The other way, when we solved it before, we divided both sides by cos, and what do we get on the left? We get sine over cos, which is just tan, and then you get tan x equals 1. When is tan x equal to 1? Well, quadrant 1 and quadrant 3, pi over 4 family, so you get the same answers of pi over 4 and 5 pi over 4 again. Still need to solve this side. When is cos equal to 0? Pi over 2 and 3 pi over 2. Check our domain. Our domain is fine because it's between 0 and 2 pi. 2 pi wasn't included, but that doesn't affect us because we didn't get 2 pi as one of our answers. Now, there are a lot of questions that we can do for practice from the textbook, questions 12 through 15. And then on that identities sheet, we've done the first side, which was all of our proofs. On the back side is a bunch of solving questions. The ones that are good for practice, and they switch between using calculator and using all of your strategies, so they are really good for practicing because you have to think on each one of them what you would need to do. Are those questions. And we are going to use the rest of class now to work on those.